Hey Precalculus. So we've been looking at rational functions in class, and here are 4 keys to graphing any rational function. The first and easiest thing you want to do is find your y-intercept, and you're going to do this by plugging in x equals 0. After that, you're going to find your x-intercept, or possibly intercepts, by substituting y equals 0 and then solving for x. So these are sort of the same steps, but in opposite variables. The third thing you're going to do is find your vertical asymptotes by setting the denominator equal to 0 and solving. That's going to be whatever causes your domain problem. And then last but not least, you're going to find your other asymptotes by using long division. And this asymptote's always going to be in the form y equals the quotient. So to see this in a real example, I know we've been doing these in class. If I take a look at this rational function, the first thing I'm going to do is find my y-intercept. When I find my y-intercept, I do it by setting x equal to 0. So I have r of 0 equals 0 cubed plus 0 squared over 0 squared minus 4. That's 0 over negative 4, which is 0. This means that my y-intercept is 0 for the x, because I plugged in x equals 0, and 0 for the y. There's one crucial piece of information. Now, because it's 0, 0, it means that this one is a y-intercept and also an x-intercept. So this is one of my x's also. Now I'm going to find my x-intercepts. So that's by setting y equal to 0 and solving. So I have 0 equals x cubed plus x squared over x squared minus 4. I can multiply both sides by x minus 4 to cancel it out of the denominator. When I do that, 0 times anything is 0. And so I get 0 equals x cubed plus x squared. Since there's more than one x in this problem, we're going to have to factor to solve this. So I see that I can factor out an x squared, and I'm left with x plus 1. This means that x squared equals 0, or x plus 1 equals 0, so x equals 0, which we already found up here, and x equals negative 1 is also another x-intercept. So my x-intercepts are 0, 0, and negative 1, 0. Okay. After I find my intercepts, I'm going to find my vertical asymptote by setting, I'm going to call it the VA for vertical asymptote, by setting the denominator, x squared minus 4 equal to 0, and solving. So here I can factor this. I get x minus 2 times x plus 2. So x equals 2, or x equals negative 2. This means that I have 2 vertical asymptotes. X equals 2 is one vertical asymptote. X minus 2 is a second vertical asymptote. And then last but not least, I'm going to do long division to find my horizontal asymptote. I'm going to call that, or it might be a slant, so maybe I'll say SHA, slant or horizontal asymptote. Let's see, for long division, I'm going to say x cubed plus x squared plus 0x plus 0. Put my space holders in there. And I want to see how many times x squared minus 4 goes into it. X times x squared gives me x cubed. X times negative 4 is a negative 4x. I change the signs, so then I bring down my x squared because these x cubes cancel. I get plus 4x plus 0. X squared and x squared goes in once, so I get a plus 1 there. 1 times x squared is x squared. 1 times a minus 4 is a minus 4. And then I switch the signs, and I get 4x plus 4. Now, I can stop here because x squared doesn't go into 4x. There's nothing that I can multiply. I also know I'm done because I've run out of room. I've done my x's and I've done my whole numbers. There's no more space out here. Since I don't have to worry about the remainder because all I want is the quotient, I've got my answer here. My asymptote's going to be y equals x plus 1. And in this case, it's a slant asymptote because it's got slope to it. It's a slanted line. So now that I've got these crucial pieces of information, I can go to my graph. When you graph a rational function, start by graphing these pieces that you found. It's the first thing you want to do. So I graph 0, 0 for my x and y-intercept, negative 1, 0 for my other x-intercept. I have asymptotes, vertical asymptotes at x equals 2, and x equals negative 2. So these are guiding my behavior of my graph. And I have a slant asymptote at y equals x plus 1. So let's see, that's up 1, and then the slope is 1. So I'm getting this linear function here. Now, it's okay that one of my intercepts lands on my asymptote. Slant and horizontal asymptotes, the graph can actually cross. It just guides the end behavior when x gets really, really, really big in the positive direction or really big in the negative direction. The last thing you're going to want to do is fill in your points. To do this, you can make an XY table and do it by hand, obviously. You can also, at this point, to save time, use your graphing calculator. So we've got the function plugged in. I took time to put parentheses around the top part of the fraction, the numerator, and parentheses around the denominator. And then if I go to my XY table, I can pull off some points here. So for instance, let's see, -3 is -3.6. So back 1, 2, 3, 1, 2, 3, and a little more. Okay. So I only really need 1 point here because these arrows or these asymptotes are guiding my behavior. I'm going to get closer and closer to each asymptote. So I can sort of draw my curve in there because it's going to have to fit between these two lines. They're sort of like guidelines. And then let's see, I've already got this point here. Let's see what happens at 1. So at 1 I'm at -0.66. So over 1 and down almost 1. Okay, and again, my asymptotes are going to guide my behavior here. So it's going to come up a little bit and then dip back down. And then let's see what's happening at like 3 on the other side of this asymptote. So if I go to my graphing calculator, I'm at 7.2. So over 1, 2, 3, up 1, 2, 3, 4, 5, 6, 7. Didn't plan that out very well, did I? And again, my asymptotes are going to guide my behavior, so I'm going to get closer to this asymptote and closer to that asymptote. And then if I hit graph on my graphing calculator, sure enough, oh, so I made a mistake here when I went down. I assumed that the graph would go down here, but it didn't. Now to see that, I might have to adjust my table set. So I'm going to start at, let's see, -2 and go by 0.5s. Now when I go into my graphing calculator table, if I look at like -1.5, I see that it actually goes up to 0.6, so not quite 1. So it's like this. And then if I table set again, I made it change by 0.1s. Let's see. Yep, and sure enough, like -1.9 goes up to 8. So if I were to go back 1.9, it would go all the way up to 8. So this is actually going up like this. And that means this actually has to dip below for it to go below 0. So if you make a mistake like that in permanent marker, which I hope you didn't, maybe go back and like fix it with a highlighter. Preferably though, it's going to be easy to make mistakes on these. Please use pencil. That would be your best bet, which I should remember for next time. Alright guys, that's it for your 3.6 notes. Have a good night and I'll see you tomorrow.